My dear students, Assalamu alaikum. Today we will discuss the last topic of the elimination reaction, which is 1,1 or alpha elimination reactions. As you know, that alpha elimination reactions are those reactions in which both the atoms or groups leave from the same carbon atom, and these type of elimination reactions are called alpha or 1,1 elimination reactions. So for alpha or 1,1 elimination reactions to occur, there are some conditions. These are very rare type of reactions. The first one condition is that the compound must have a powerful electron withdrawing Y group. It means the leaving group will be very powerful because when it withdraws leaving group, so it will remove the electron density from the hydrogen of the alpha atom, and so alpha hydrogen, the hydrogen present on alpha carbon, it is very much acidic and it will leave. And the second is by using very strong base. When you use a strong base, so strong base will remove the proton which is very acidic. So the alpha proton is very much acidic, so it is removed in place of the beta proton. And the third one condition, which is not compulsory, that by the absence of beta hydrogen, so compounds in which beta hydrogen is not present, so all these compounds will undergo elimination reactions through alpha or 1,1 elimination reactions. One of the example is this one. For example, in this compound you can see that the chlorine is attached as a leaving group. Now chlorine is a very good electron withdrawing group, so this chlorine will remove the electron density from this carbon, as a result that this carbon proton, which is an alpha proton, which is become very much acidic. So base, which is a very strong base, will remove the proton from the same carbon, and from the same carbon chlorine is also removed, so you will get a carbene. And as a result, how the elimination reaction will take place, completes. So what happens, that the proton from beta carbon comes to this carbon and the electrons comes to this double bond. As a result, you will have elimination reactions. So how the elimination reactions are completed? First, the base will remove the proton from alpha carbon, and the Y group, the leaving nucleophile, also leave from the same carbon. You will get a carbene. So suddenly this proton from the beta carbon proton migrates, rearranges and comes to this carbon, and double bond is formed. So these type of reactions, they are called the 1,1 alpha elimination reactions. Now what is the proof of this 1,1 elimination reactions? Now if we want to give the proof, there are two proofs with the help of isotopic labeling. So I will give you the proof of this 1,1 elimination reaction. Okay, my dear students, now we want to give the proof of the 1,1 elimination reactions with the help of isotopic labeling. So first proof will be given by using this compound. If we use this compound in which the alpha carbon contains two deuterium atoms instead of the simple proton, so what happens in the first step, this deuterium and chlorine will be removed to give you this carbanion, and the beta hydrogen then comes to this carbon and will get this compound. So if we will start with a compound which has two deuterium atoms at this alpha carbon, and at the end we will have a deuterium at a terminal carbon atom, it means the reaction takes place through 1,1 elimination reactions. The second proof comes from the compound in which we use the two deuterium atoms at beta carbon. This is alpha carbon and this is beta carbon. In first compound we will use two deuterium atoms at alpha carbon. Now in the second compound we use a compound in which the two deuterium atoms are present at the beta carbon, but the alpha has no deuterium atoms. So what happens is from the alpha carbon a proton and chlorine is removed to give you the carbanion, and now the deuterium from the beta carbon will be migrate to alpha carbon, and at the end we will have one deuterium atom at one carbon and one deuterium atom at one alpha carbon. This will also prove the reaction takes place through 1,1 alpha elimination reactions.